Okay, so now we'll make a video that uses the sine and the cosine ratios as opposed to just the tangent ratio. So, if you remember from the last discussion, we know that the tangent ratio was always written as the opposite side divided by the adjacent side. Well, the other two ratios are called sine and cosine. Sine is abbreviated as SIN. It's the ratio between the opposite side and the hypotenuse instead of the adjacent. So it's still the same kind of idea, just instead of using these two sides, it uses the opposite and the hypotenuse. Likewise, cosine is abbreviated COS, and it uses the adjacent and the hypotenuse. Okay? So now, let's do a couple of examples. So let's look at the first one here. So we'll make a triangle, and x and 8 with a 20-degree angle. Okay? Label your triangle first of all. This is my right angle, so that means the hypotenuse is across from the right angle, which is the side length 8. The angle of interest is right here. That means over here I've got my opposite side, and down here is my adjacent side. So now, which ratio do I need to use here? Well, I know that I have the length of my hypotenuse. I also know that I want my opposite side. So that means I need to use the ratio that has the opposite and the hypotenuse. So the opposite and the hypotenuse is my sine ratio. So I know that for this one I will be using the sine ratio. So I can say that the sine of my 20-degree angle is opposite over hypotenuse. So I can say the opposite side length, I don't know, it's x. My hypotenuse I know is 8. I can find out what the sine of 20 degrees is. It works the same way as tangent, just instead of hitting my tan button, I hit my sine button. So I clear this off. I'm going to hit sine and type in my 20 degrees, my 20. That gives me 0.342. So that tells me again that for every 20-degree angle, the ratio between the opposite and the hypotenuse will always be 0.342. I can make that a fraction to cross multiply. So in this case, x will be equal to 8 times 0.342, then divide by 1. So then I would just take the 8 and multiply it by the 3.42, which gives me approximately 2.7. So I can say that this side length is about 2.7 units long. Okay, so that's using the sine ratio, and we found the opposite side. Let's try another one here. Alright, so let's take let's say we know that this is 12 and we're finding this. We'll use, say, a 50-degree angle this time. Okay, so started by labeling the triangle again. Here's my right angle. My hypotenuse is over here. This is my angle of interest, so my opposite side is across from it over here. That makes my adjacent side down here, the 12. Alright, so I need to find out what ratio to use here. Well, I know what the adjacent side is. The adjacent side is 12, and I want the hypotenuse. So that means the ratio that I use needs to have the adjacent and the hypotenuse. Which ratio uses adjacent and hypotenuse? Well, you can look at them, and you can see adjacent and hypotenuse would be cosine. So I've got cosine of 50 degrees equals adjacent over hypotenuse. Alright, so my adjacent side is 12. My hypotenuse is x. Cosine of 50 degrees, I take my calculator again, clear that. So I'd hit the cosine button this time, COS. So COS, type in 50, press enter, so 0.64. Since this is a 7 right here, I would round that to 0.643. So I would have 0.643 over 1 equals 12 over x. So now to solve for x, I would do 1 times 12 and then divide by the number that's left over, the 0.643. So I'm taking 1 times 12, of course, is 12, and I'm dividing by 0.643. Rounding off, this gives me about 18.7. Okay? So I can say that this is approximately 18.7 right there. So you might be asking, is there an easy way to tell whether I'm going to be using the sine ratio, the cosine ratio, or the tangent ratio? Well, there actually is. There's a little mnemonic device to help you remember which side lengths the sine uses, or which sides the tangent uses. And it's so ka toa. So this really tells me that the sine ratio is the opposite over the hypotenuse. Okay? This tells me that the cosine ratio is the adjacent over the hypotenuse. The tangent ratio is the opposite over the adjacent. So from this mnemonic, so ka toa, I can say that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. Okay? So let's do one more example and then finish it off. Another sheet of paper. Let's actually find an angle this time, because we can find angles using these as well. Alright, let's say I want to find out what this angle here is, and I know that this is a 7, and that's a 15, or a 15, not 115. Okay? So this is the angle I'm trying to find. So, well, first of all, right angles here, so that makes the side that's across from it here the hypotenuse. This is the angle that I'm trying to find. So across from that angle is my side length of 7. So this would be my opposite side. This side down here is left over. It's the side that's next to the angle, so it's the adjacent. Now again, I ask myself, which side, in this case, which sides do I know? In this case, I know the opposite is 7 and the hypotenuse is 15. So I need to use the ratio that has 7, opposite and hypotenuse. Well, if I remember, so ka toa, I'm looking for O and H, right? Well, O and H would be right here, so this tells me it's the sine ratio. So I would say, okay, the sine of my angle is my opposite over my hypotenuse. Alright? So sine x is equal to, fill in the lengths again. Opposite is 7, hypotenuse is 15. So then I can say that x is going to be, first of all, actually, I divide these numbers, right? So 7 divided by 15. So 7 divided by 15. It's approximately 0.46 repeating. So 0.46667, we'll say. So then, in this case, x will be, instead of the inverse tangent, it's going to be the inverse sine of 0.46667. So x is equal to, I can clear that. So I see that my sine button is here. Above my sine is my inverse sine. So I hit my shift, or my second function button, then hit my sine, and I type in 0.4666667. Okay? Close it off, and that tells me that the angle is about 27.8 degrees. So you see that all the same techniques that you used using the tangent ratio still apply with sine and cosine. You're just hitting a different button. That's all.